So in this lab video, we're going to show the 4 exercises of lab 5. And in exercise A, we are going to use the Raspberry Pi. So after we physically connect the Raspberry Pi to our computer, we need to do some network connection configurations, just as shown here. So here the IP address is 10.0.0.1. Then we can use PuTTY to connect to the Raspberry Pi, and the host name is 10.0.0.2. The username and password are both Pi. And then we can use the VNC viewer to visualize the Raspberry Pi. The VNC server address is also 10.0.0.2. And both username and password is Pi. So this is the desktop of your Raspberry Pi. So the next step is to test the sensor. First, we need to create a Python script called dhtsensor.py. And then here, write the code below. And adjust the code format. And then save the script. And execute the script. So you can see that the real-time temperature and humidity from the sensor are printed here. So the next step is to send the data to ThingSpeak. So first you need to create an account. I will skip this step, and because I already logged into my account. And then you need to create a new channel with the first field of temperature. And the second field of humidity. And then you need to modify the previous Python script with the following code. And then replace the write API key and channel ID here with your own data. Then execute it. So you can see that the data are plotted on your channels in the ThingSpeak. The next step is to visualize your data via a NodeRED. First, you need to install the NodeRED on your Raspberry Pi. You can refer this to the document in the Lab 4. So you can find the installation command on the Raspberry Pi website. And then you can copy this command to your PuTTY, which has already been remotely connected to your Raspberry Pi. So after you successfully installed the NodeRED, you can run it, use the command NodeRED. And then you can access the NodeRED interface with the address of your Pi IP, which is 10.0.0.2, and the port of 1880. And we can search for the nodes in the left column. For example, for the HTTP request, and we can drag it to the flow. And if you find that any node is missing, you can try to install it here. So first we need to configure the HTTP request node to pull the data from the ThingSpeak. You should use the method of get and the URL of the following. We need to replace the real channel ID and the read API key. Then we need to configure the gauge node to visualize the data. So we can set the name as temperature and the tab as home. So this means that the data will be presented on the UI page. And the label can also be set as temperature. And the value format should be message.payload.feed0.field1. And the maximum of the range should be also set 100. Then we can connect the HTTP request node to the gauge node and insert an inject node. And connect the inject node to the HTTP request node to continuously get the data. Then we can access the UI page to verify the gauge. It can be seen that the data is presented. Then we can insert another gauge node to present the data of the humidity. Similarly, we can set the name as humidity and also choose the tab of home. And this value format should be message.payload.feed0.field2. And maximum of the range should also be set 100. And deploy. So now you can see that both the temperature and humidity data are pulled from the ThingSpeak and presented on this page. Then we are going to do the exercise B. So in exercise B, we are going to read the data from a CSV file instead of the real-time data from the sensors. So we create a new flow and insert a read file node to read the data from the file. So we can fill in the file paths here. Then we use a function node to parse the data. Use the following codes. Note that the punctuation here should be exactly the same with the actual split punctuation in your CSV file. So if you are not sure, you can open it to check. And then we need to transmit the data to the ThingSpeak via MQTT. So we need to drag the MQTT out node and configure it. One for temperature and one for humidity. So we can use a public MQTT broker address like this, and the topic of home temperature and home humidity. And then we can use another two functions to get the parsed temperature and humidity data. And connect them to the two MQTT out nodes. Then we need to send the data to the ThingSpeak. So we now need two MQTT in nodes with the same server address and the same topic as we write before. Also one for temperature and one for humidity. And then we should use two HTTP request nodes to send the data to ThingSpeak with the method of post and the URL as follows. Similarly, you need to fill in your real write API key. And then connect all the nodes. and insert an inject node to trigger. And deploy. Then we need to open the MQTT client to verify the data. So we need to create a new connection with the broker address of the public one, which we filled before. And connect. And we need to subscribe the topics we filled before, which is home humidity and home temperature. So you can see the data is presented here. And when you go to the ThingSpeak, you can see the data are also sent here. And then we are going to do the exercise C, which we need to simulate and publish the temperature and humidity data using NodeRED and MQTT, instead of reading the data from a CSV file or use the real-time sensor data. Similarly, we also need to use the MQTT broker and NodeRED in this exercise. So first we create a new flow and drag the inject node to trigger and two function nodes to generate humidity and temperature data, and also MQTT out node to publish the data to the MQTT broker. So first we configure the inject node. We set the payload type as timestamp and set the repeat option as repeat every 5 seconds to continuously generate the data. And we can also give it a name, for example, generate data. And we configure the first function with the following nodes, with the following codes to generate the humidity data. And the second function to generate temperature data. Then we configure the MQTT out node. With the previously written public MQTT broken server address and the port of 1883. And we can leave the topic empty. Then we can open the MQTT client to verify the data. So we need to subscribe the two topics as we written in the codes. For example, the home temperature and the home humidity. So you can see that the data are received. And the data are being published every 5 seconds. Finally, we are going to do the exercise D, which where we need to observe the MQTT input in the NodeRED. So first we drag a MQTT input node and configure it using the previously written server address and the topic. And we can name it as temperature input. And another MQTT in Node for the humidity. And then we add two debug nodes to get the data subscribed from the MQTT broker. And deploy. And then we can manually publish some data to the MQTT broker. For example, for the topic of home temperature, we publish a data of temperature, which is 25. And after we click publish, the data is shown in debug 1. And for humidity, we can publish a message of humidity 60. And then we can see that the data is presented in the debug node 2.